Kayla, for part A, I took 20 over 20 times 100. Cannot be 20 over 20 because the original, okay, let me address this. 20 over 20 times 100 is not correct because why? The original is not 20 units. The original is 10. So then when the teachers see this, they know that this is not correct. Okay, so take note of it. Okay, now next. A box contains black beads and white beads. At first, the number of black beads was 1/3 the number of white beads. This one is very important. 1/3 of the number of white beads. So 3 is white, then 1 unit will be referring to the black. So in comparison, okay, black to white is, okay, if I want to write black to white, it will be 1 to 3. Okay, in ratio. Next, after 1/4 of the black beads and 3/8 of the white beads were used, this is of the black beads, this is of the white beads. Okay, then 63 beads were left. So obviously, this question is a BCA question and both quantities changed. However, they give you a proportion, okay? Proportion was given for the before stage. So there's no need to use units and parts. You can actually use ratio to help you with this question. You don't need to draw model, but model can be drawn as well. So I'm going to go with the ratio method first, which is the first method that you should try to use whenever it's a before change after question. BCA means before stands for B, C stands for change, then A stands for after. Okay, now we go on to the next part. So I'm going to come up with the ratio. Black to white. Okay, it will be 1 to 3. So this is the ratio for before. Now, we're going to work with the after. They say after 1/4 of the black and 3/8 of the white. So what I'm trying to do is I have to try to make it to numbers, okay, instead of working with fractions. So this means that black beads, right, should have 4 units. So what would I do now? Okay, because 1 to 3 is a ratio, we try to make it proportional, right? And we will find the equivalent ratio. So I want to make my black become 4 units. So what would I do? I times 4. And this will give you 12. Then now you ask yourself, okay, 3/8 of the white beads. So that means white beads need to be 8 units. But currently my white beads is 12. So we want to find a common multiple of 8 and 12, which will give us 24. So I want to make it all in units so that it's all in whole numbers, so it's easy for us to work with and to work with fractions. So what I will do, okay, so I'll times 2 here to make it 24. Because it's ratio, it has to be equivalent. You do to one side, you have to do to another side. So times 2, you will give 8. So this is the ratio that I have right now. Okay, so I'm going to work out the change. 1/4 of the black beads. Okay, so 1/4 times 8 units, I'll get 2U. Okay, so this is the part that is being used. Then 3/8 of the white. Okay, so 3/8 out of the 24 units, in total is 9 units that were used. So I can make use of this, okay, to continue and find my after ratio. What's my after ratio? So black minus 2U, then white minus 9U, which will give you 6 to 15. So this is the after ratio. Okay, later on, I will just show you at the side, right? If I were to work using the original ratio, I will just end up with decimals, which is also fine. Okay. So now, we go on to see how many beads were left. Okay, before that, they ask, what fraction of the beads were used? To find used, okay, you have to put used out of the total. Okay, what's the number that was used? 9 plus 2 units. Total will be 8 plus 24. So in the end, you will get 11 out of 32. That's for part A. Part B, Okay, how many bits were in the box at first? So the only number that you're given, it is the 63 bits that were left. So you need to go and look at the after ratio. Okay, I will answer all the questions later after I finish going through, okay? Just give me some time. So at the end will be 16 units plus 15 units. That will give you 63, okay, bits that was left. So 21U is the same as 63. 1U will be 63 divided by 21. I will get 3. What do they want? How many bits were in the box at first? We already know the ratio, the fraction is 11 out of 32. So total will be 32 units, okay, for the number of bits at first. So that will give me the answer 96. Okay, so now, okay, before I answer the question, I'm going to show you if you decided that I don't want to make it whole numbers, I can work with fractions. Then just go ahead to work with fractions. So this part will not change. Okay, okay, let me just show you. Okay, I'm going to show you here. If you were to work with just fraction, it is also fine. So for example, I know, okay, this is minus 1/4 of the black. Okay, this is minus 3/8 of the white. So what would I do? 1/4 of 1 unit is the same as 1/4 unit. So I will left with 3/4 unit. Then 3/8, okay, of 3 unit, you will get 9 out of 8 unit. Then in the end, okay, you will have 1/7 out of 8. So you subtract. So when you have, okay, fractions, it still, okay, can be worked out. Just that some students are not comfortable. So usually I change to whole number. But we know that this is the end. Okay. And so we need to use this later on to find for part B, which is all these units here, 3/4 units, okay, plus 1/7 out of 8 unit will, okay, give you 1/8. This is 13 out of 8. Okay, so this number of units, I make it to mixed number, okay? So this number of units will give you 63 bits that's left. Okay, so this is by using fractions. So the only thing trouble with this is that for part A, then you have to go and think. In terms of fraction, okay, what's the total number of bits used? So you will put 1/4 plus 9/8, okay, because used is here. Then the total will be 4 units. So if you key this into the calculator, okay, show you 1/4 plus 9 out of 8, okay. Okay, so 1.375 out of 4, you will get 11 out of 32 as well. Just that, okay, sometimes it's not comfortable for students to see, okay, I have a fraction on top, then out of a whole number. But you have a calculator, so it doesn't hurt for you to key the whole thing to calculator lah. So it will still work. Just that you will be working with fractions. So if you're uncomfortable, then use the whole numbers. That means you keep multiplying until you can work with just numbers, whole numbers and no fractions. Okay, so now I'm going to look at the questions that you're asked. Okay, for Jun Kai, I did not write the ratio, but I used the ratio numbers. I times 3 all the numbers and got correct. If you did not write the ratio and your method shows that you understand the question, and if we see that there's method there, we will award method. Okay, so that one I can only see when I have the solution. Okay, but as long as, even if you don't write ratio, sometimes students can work without the ratio part here. Okay, sometimes students can visualize and they can just go straight to here. It's fine as well. Okay, but what I'm showing here is that I want everybody to understand what's going on in the before stage and the after stage. And then if I want to use the ratio method, how can I get rid of all the fractions? So if you are a person that really don't like fractions, then you should try to make your ratio bigger so that you are working with whole numbers only. Okay, so now next.